Hello and welcome back to the Industrial Bootcamp series. This is episode number 10. My name is Kerry Rose. I'm the Industrial Channel Account Manager for the Southeast. With me again today is Marty Reagan, Industrial Channel Account Manager for the South Central, and Nick Weissong, Technical Sales Engineer for the Southeast, South Central, and West. This episode is called See You at the Edge. Note we're using the periodic table. We're going to be discussing copper cable and its connectivity. Next slide, please. How much time is spent troubleshooting an industrial Ethernet network only to find out the cabling is causing a majority of the problems? Reliable connections are the key to maintaining a high operational equipment efficiency. As we get closer to the edge, the structure and the deployment of the cabling becomes a little more unique and a little more difficult. A well laid out network is only the start. A well deployed network is the end game. Next slide. When it comes to media criteria or media selection, it's imperative that you plan for the future. Things to consider include bandwidth and the environment in which the cable is being placed. Remember mice? The other selection criteria include when to use shielding or when to use stranded cable. Is PoE application or is PoE required? Redoing cabling on the plant floor is difficult at best. Adherence to proper installation techniques and methods supported by proper standards, compliant testing will decrease commissioning time and will prove out that the installed cable meets or exceeds the TIA standards in terms of headroom and application support. Category and category cable rating are part of the TIA standards, and today we really are recommending installing category 6A for most of our industrial applications. If you look at the ratings and what their bandwidth capacities are, it's obvious that there are significant difference between category 5E and category 6A in terms of expected performance and data rates. Category 6A in terms of price to performance is a significant value over category 5E. For extreme applications, especially in extremely harsh environments, Panduit does offer a category 7 option. This cable has been designed to support 600 megahertz, but our cable has actually been tested to 1,000 megahertz. And now I'm going to turn over to Nick as we discuss where these cables will be installed and their deployment.
Thanks, Kerry. Once you've established a strong fiber backbone, it is time to get the information down to the edge device. The best way to do that is with the proper copper cabling. This is where we need to start paying closer attention to the mice ratings to ensure we specify the right cable for the right job. This slide shows 3 different copper cabling subsystems. Subsystem 3 is showing how copper is used in the micro data center. In this subsystem, we are using enterprise jacks and enterprise patch cords to maintain our structured cabling within the cabinet. The cabinet is either in a mice level 1 or the cabinet is a higher NEMA rated cabinet protecting the equipment and the patching inside. So the enterprise grade patching is suitable for this application. In subsystem 2, we're starting to reach mice level 2, where we start to think about using shielded cables and shielded jacks. Some of the copper may reach outside the cabinet, and it's not just self-contained within the cabinet like the MDC. If shielded cabling is required, we need to maintain the bond throughout the entire subsystem. This means using all SDP cable, jacks, patch cords, and patch panels to maintain proper performance. Some system 1 is going to reach the highest mice rating areas. This is where we're going to start thinking about 600 volt rated cable, as well as some harsh environment patch cords like the M12 patch cord sets. Panduit's TG modular jacks are designed to optimize performance and reduce crosstalk as well as unwanted noise. These jacks are also designed with the contractor in mind because they can be terminated 50% faster than our competitors. Panduit also 100% tests all jack modules to ensure proper performance in the field. The final thing that I want to mention before handing it off to Marty is the new shielded field term plug. It's now designed with the same cap as the jacks to make it easier and faster to deploy, which will save you money and time over the course of the project. Marty?
Thank you, Nick. The copper cabling infrastructure as it is deployed to the edge faces many challenges: overcrowding, noise, damage, strain, and the need to adapt to moves, adds, and changes make design considerations paramount. A chain is only as strong as the weakest link. We must not compromise the reliability of our network and all the work we've done upstream as we begin to reach the finish line. Continuing to adhere to standards and best practices will ensure success today and into the future. In this slide, we're deploying the copper infrastructure at the cell level. At the top left, our fiber uplink is terminated in the network zone enclosure and patched to the industrial switch. Two switch downlinks are patched to 2 ports on the DIN patch panel. The DIN patch panel supports the shielded solid copper permanent links out to the control panel, and the control panel accepts these permanent links using 2 single port DIN mount adapters and shielded jacks. These links are now permanent and can be tested per standard. The control panel is now set to support the edge. Internal to the control panel in the middle of the slide, we patched to an internal switch with 300 volt rated patch cords for the uplink and support the variable frequency drives, controls, and front door mounted data access port with 600 volt rated patch cords. Additional downlinks for the end devices are supported with 600 volt patch cords to IP67 rated bulkhead adapters and couplers, which support RJ45 and M12 connectivity. To the right of the slide, using point-to-point direct cabling, we connect a robot enclosure, a machine enclosure, and a wireless access point with mice appropriate cable and various connectivity mediums for each application. Next. Next slide. This slide gives us a closer look at a typical permanent link from an industrial enclosure to a control cabinet. You will see the switch downlinks patched over to the DIN patch panel in the zone enclosure, the RJ45 jack in the zone to the RJ45 jack in the control cabinet is our permanent link. When we complete the patching through the DIN adapter in the control cabinet, we have completed the channel. Many network issues are at the patch cord. Insist on factory terminated patch cords that have QC tracing to ensure performance. Next. In this episode, we discussed the copper cable and connectivity supporting the architecture throughout all cabling subsystems. We will continue with the TIA model next time as we move to the edge and integrate the control cabinet into the architecture. Next. Thank you for joining today. Join us for episode 11 titled The Fridge as we discuss the connected control cabinet. Please feel free to share these short recordings and reach out to your local territory account manager or contact one of us directly if you need further assistance. We'll also post this on our LinkedIn pages as a format to share as well.